Okay, part A. Sketch the curve with equation y equals 3 times 4 to the x, showing the coordinates of any points of intersection with the coordinate axes. Okay, so guys, this is literally your exponential or power graph. Now, exponential power graphs always take this form. It's always y equals a times b to the x, yeah? And the typical shape is always the same. There's literally no difference. You always got your x-axis like this, and you have a y-axis, and the curve looks a bit like this, shooting upwards and never touching the x-axis, yeah? And as for the y-intercept, it always hits at the point A, so wherever the constant is in front of the bx. In our case, it's 3, yeah? So actually, this graph is the same thing, but instead hits at 3. And that's it, guys. This is literally all you have to do. Now for part B, it says that the curve of equation y equals 6 to the 1 minus x meets the curve of equation 3 times 4 to the x, so basically the same one, at the point P. And they want us to show that the x coordinate of P is given by this log expression right here. Okay, so when two curves meet, that literally means to equate these together, yeah? So essentially we have this, guys. We have 3 times 4 to the x, which must equal 6 to the 1 minus x, okay? And to resolve this, guys, you can just take logs on both sides, and that's personally the easiest way to do it. So taking logs on both sides, you can have log 3 times 4 to the x equals log 6 to the 1 minus x. Now, some of the properties of logs is that if you're multiplying inside, it's like adding two separate logs. So we're going to have log 3 plus log 4 to the x. And then when you've got powers involved, and when you've got powers in the log expression, these go in front of the log. So the 1 minus x goes here, so 1 minus x times log 6. And again, repeating on the left side, guys, you got log 3. The log 4 to the x becomes plus x times log 4. And we could just expand the right hand side, yeah? Open the bracket. So you got 1 times log 6 is log 6 minus x times log 6. Okay, so I think we're almost done. Now all you want to do is literally move the x terms to the left and the non-x terms to the right. So I'm going to plus x log 6 across and subtract log 3. So this means you're going to get x log 6 plus x log 4. And on the right, you now have log 6 minus log 3. Okay. So on the left hand side, we can now isolate the x by factorizing it out here. And inside the bracket, you're going to have log 6 plus log 4 is now going to equal log 6 minus log 3. And finally, one more step, you can now just divide this bracket across here, and you're going to be given x equals log 6 minus log 3 all over log 6 plus log 4. Now this is actually the answer, but they want it in a particular form, right? And it does look kind of different. Now, what you can do is still apply more log properties. Two of the properties are here. If you're subtracting two logs, it's like dividing the terms. So it's like saying 6 divided by 3. This is going to give us a log 2, okay? Because 6 divided by 3 is 2. For the bottom, when you're adding logs, you multiply the terms. So it'll be 6 times 4, which is 24. So you're given log 24 on the bottom. And now, notice how they have little base 10s as well. Thankfully, in logs, you can literally stick in the same base up and down. So this is the same as log 10 2 over log base 10 24. And by the way, guys, a regular log is the same as log to the base 10. So these are actually identical expressions. But yeah, guys, this is it for question 9. And finally, guys, number 10. So a curve C has equation y equals 4x cubed minus 9x plus k over x for positive values of x, where k is a constant. Now the point P with x coordinate a half lies on C. Given that P is a stationary point of C, show that k is negative 3 over 2. Alright, when you have stationary points, this literally means that you want to differentiate and set dy over dx over 0. Because stationary points are essentially turning points with flat gradients, yeah, where dy dx is 0. So flat gradients means dy dx is 0. Now before we differentiate this, it's very important that you put all of this into indice form. So all the x's must have powers. You can't have fractions. So what I would do, guys, is I would rewrite this y equation and keep the first two terms, keep 4x cubed minus 9x, but then change k over x. So if you got x at the bottom, to bring it to the top line, it becomes x to the negative 1. So it becomes plus k x to the minus 1. So this is the reciprocal index here. Now we want to go ahead and differentiate this. So I'm going to try and bring it down a bit. So to differentiate that, so this is part A. Let's write dy over dx. The rule to differentiate is that you just have to drop the power. So it'd be 3 times 4, which is 12. And then subtract the power by 1. 3 take away 1 is 2. For the next part, if you're left with just an x, that vanishes, so you get minus just 9. And again, for this one, you drop the power down, so it'll be minus 1 times k, which is minus k x, and subtract the power by 1. Minus 1 take away 1 is minus 2. Okay, so this is good. And if you remember, because it's a stationary point at the point x equals a half, we're going to set dy dx to 0, yeah? So we say, okay, when x is a half, dy over dx is 0. So now, just doing both of them, this means we got 12 times a half to the power 2 minus 9 minus k times a half to the negative 2, and it's all supposed to equal 0. So all you got to do now is just tidy all of this up. So I would put the first two terms in the calculator, and doing so, you're going to get a minus 6. And if you write a half to the power minus 2 in the calculator, you're just going to get a 4. So this would be minus 4 times k. And that all equals 0. Now this is straightforward. You just have to make k the subject to get minus 3 over 2. So just rearranging this, you can see that k is now going to equal 6 over minus 4, which is actually minus 3 over 2. And that's A done. Now for part B, we need to determine the nature of that stationary point at P. In other words, we need to find the second derivative and check if it's greater or less than 0 at x equals a half, yeah? So let's do that right now, guys. Let's get the second derivative. Now for part B, we can say second derivative is d2y over dx squared. So differentiating this expression, 12x squared becomes 24x because you just drop the 2 down. 9 disappears because it's a constant. And then minus kx to the minus 2. Well, all you do is drop minus 2 down, so it becomes plus 2k. And then subtract the power by 1, you get minus 3. Now we know what the value k is, don't we? It's actually minus 3 over 2. So we can say, okay, this is the same as 24x. And so 2 times minus 3 over 2 is actually minus 3x to the negative 3. Now, to determine the nature of a stationary point at P, we just plug in the x coordinate at P, which is a half. So next we say, okay, at P, when x is a half, we have d2y over dx squared equals 24 times a half minus 3 times a half to the negative 3. Literally put that in your calculator, guys, and you get a negative result of minus 12. And this is less than 0, so this is actually a maximum point. So x equals half is a maximum. And that's literally it for part B. And finally, for part C, we are told that the curve C actually has a second stationary point. Now, using algebra, find the x-coordinate of this second stationary point. So stationary points can actually be found when you have a dy dx equation and you set it to 0 and you solve for x. Now, because it's telling us that there's two stationary points, this is probably telling us that the dy dx equation is actually a quadratic equation. Because two stationary points, well, usually that's what it would imply. So guys, I've already gone ahead and copied out the dy dx equation here, and I've replaced the k with minus 3 over 2, so it looks a bit like that. And because we're going to start from here and set it to 0, this is where we're going to try and solve. So to solve an equation like this, it's probably better we get rid of any negative powers, yeah? So I would probably times everything by x squared, so this part cancels out, yeah? If you do that, we're actually going to get 12x to the power of 4, and then minus 9x squared, and now we're just left with 3 over 2, and this is equal to 0. So actually, guys, if we look at this carefully, this is secretly a quadratic in disguise. And if you want to make it easy for yourself, you can say something like, let, I don't know, z this time equal x squared. And if you do that, you'll actually have something like 12z squared minus 9z plus 3 over 2 equals 0. And yeah, this can easily be solved using a quadratic formula. So just using a quadratic formula, guys, it's going to be something like z equals minus b plus minus the square root of b squared minus 4ac all over 2a, where in this case a is 12, b is minus 9, and c is 3 over 2. But I'm just going to write that as 1.5, yeah? And if you put this, you're going to get two z results. The first one is going to be a quarter, and the second is going to be a half. Okay? And since we know that z equals x squared, so we can just update this saying x squared equals a quarter or x squared equals a half. To find x, you're just going to square root both of them, yeah? Square root both sides, you're going to get a half here. And squaring this one, you're going to get root 2 over 2. And because we know that the first stationary point was a half, which was actually this one, this means this is the answer here. So the final answer would be x equals root 2 over 2. And that's it, guys. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go onto my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.